Thank you very much, Nuru Apika. Good morning, everyone, and welcome to this session. And it is wonderful to see University of Cyberjaya is really putting a great effort to play a very important role to look at food security and addressing the SDG 2 for the country. And I think this is something that we can see that food security is the role for all of us to play. Yeah, all of us have a significant role to play here, and that we see today. I think we have three speakers that will present to us their exciting work and contribution to help us forward and improve our food security. And in the introduction, Afika mentioned, that I'm also working on food sovereignty and also fair trade practices. So this is something when we look at SDG, even though SDG 2 is mentioned here, we try to link it also to other SDGs, especially SDG 12 on responsible consumption and production. I think I have our first speaker for today. It is very exciting. Is Francis around already, Francis? Mr. Francis Chuah, I'm so excited to meet you. Yeah, so excited, and I am so looking forward to your work. Yeah, and I understand that you have worked extensively looking at um, sustainable farming, and you have formed a social enterprise that work with various stakeholders in the country. So maybe, just to, as a founder of this, I understand you have a PowerPoint that you would like to share with us, yes?
Yeah, right.
Yeah. So I would like to give the floor to you, yeah, the screen to you, and you may share the work that you do. And later we just have very casual interaction with the question or answer with our audience. Yeah. So I pass this to you, Mr. Francis Chua. Please introduce yourself and your company. Thank you.
Thank you everyone, and thank you for the invitation from USD of Cyberjayas. We are based in Cyberjaya as well. Yeah, and okay, so let me start some presentations. Can you see? Is it everything all right? Can you see the slide? Just to
Yes,
confirm.
yes, all good.
Okay. Yeah.
Excellent.
So now we will start some introduction about urban farm tax. Yeah. Okay. Hey. Okay. So we formed Urban Farm Tech in 2016, which is quite an early date for urban farming concepts. So at the time, I was still a project manager from engineering industries, yeah, and I have 9 years of experience in engineering industries, and we are working on those like automation and so on and so forth, right? So, but when we look into our food system that we have today, we found that there is some problem that we will have to fix. But in order to fix the problem, that we think that our engineering know-how can make a help. Okay, so since 2016, we formed Urban Farm Tax, and then we look at the current situations. A lot of youth, they may not really understand what is agriculture. That's why we think that if we want to change the futures of Malaysia's agriculture system, we need to change the youth today. Okay, so what we do, we sow the seed of hope. Yeah, we inspire the younger generations about urban farmings and the technologies in agriculture. So there are a few technology that we practice in urban farm tech, such as vertical farmings. Okay, vertical farming is a technology that how we actually can grow vegetables in an enclosed environments, controlled environments, and in a vertical way, and we can use a much lesser footprint to produce more food. So second technology is the smart farming technology that apply IoT system that help us to remove monitoring what happened to the farm. And then the third technology that we focus is aquaponics technology, which is an integrated farming technology. That is a biological technology that convert the waste from aquaculture to become the nutrient for the farm, for the plant to uptake. So this is the three main pillars of technology that will focus in our project. So how we can help our customer on to kickstart urban farm project is that we through EPCC turnkey approach that we help them to do engineering, procurement, construction, and then commissioning. So this is some of our historical records. Yes, as mentioned just now, we work closely with the local stakeholder, especially in Cyberjaya. They work with Cyberview, MP Sepangs, and we also work with others, corporate like Axiata Group and Agro Banks. And we also have customer like, for example, Bandar Utama Cities. Okay, so on our social impact sides, right, we inspire the younger generation. We provide educations. We conduct the brief at school level, inspire them with modern urban farming methods such as vertical farming, aquaponic systems. So the younger generations, right, they actually feel impressed, yeah, and interest on the methods that how we can produce our food. So we also help the residential communities to set up their vertical farmings aquaponic system as well. So this is some of our track records. And as of now, we have one upcoming project, okay, uh, that is located in Cyberjaya, just within the Magic Compound. It's a collaboration with Cyberview, Magix, MTEX, and MB Banks. So the objective of this project is to become a hub, urban farm hub, to provide educations to unemployed youth, to help those unemployed youth to embrace urban farming technology, and they can make it, for self-sustainable purpose or commercial purpose. So we know that we are just a small company. We are not able to create a big impact alone. So that's why we are looking for cooperation with other entities as well. Yeah, government agencies and also other university. Yeah, because we believe that, right, all together, when we all together, we can make the thing perfect. Yeah. Okay, so that's finished my introduction, and I will start the topics today about smart farming. Okay, so this is a challenge that we found since 2016. Okay, first of all, is the average age of the farmer in Malaysia is 53 years old, and they are low in adoptions of technology, and the yield is low as well. And Malaysia itself, right, we are food import country. As of today, every year we need to import 50 billion worth of food annually. We are not aware because we have a food supply chains like, a long food supply chains from the source from other country, import into Malaysia, and through the center market to all this middleman and send into our supermarkets. So our experience, even our younger generation experience is that, yeah, use the credit card, use the money, use the cash, and they can exchange with food. That is what I found in my children as well. And that is also what triggered me, like we need to do something. We need to do something which is like let the younger generation know about that is not where we got the food. Yeah. Supermarket is not where we got the food. Yeah. So we can use our hand when there is a seed and there is a hope. So that is the things that the value that I hope to bring to the future generation. Okay. And the third challenge that we all know is that the world population is getting increased from years to years, and expected by year 2050, our global population will reach up to 9 billion, and some estimation is saying like 9.8 billion. So which also meaning to say that the demand of food, yeah, will be increased dramatically, especially urbanizations. That when urbanizations is also another trend that increase the income for for the populations, and that will also further increase the food demands. So how we can produce more food, you know, to feed the populations, and how we can make the city self-sustainable. And don't forget that they will have more populations that will move into city, and city itself have no food production functions. So that is a risk, and we have to make the change now. That's why we start urban farm tech. Okay, so there are different type of urban farming system we can adopt, to make the city more self-sustainable with a self-sustainable food system. For example, organic soil farming, fertigations, hydroponics, aquaponics. Okay, although we are focusing is on water-based system, yeah, like hydroponic, aquaponics, but still we actually encourage everyone start any urban farming system, even like or even a soil farming system, because there is no perfect urban farming system. From our point of view, from our experience, there's no perfect urban farming system. Even there's some environment it may not suitable for use for us to use hydroponics or aquaponics. They may be more suitable for you soil farming as well. Certain crops they may be more suitable for you for to use soil methods. So we would say that all these urban farming techniques is good, yeah, for a sustainable city. Okay, now we start to talk about this smart farming technology. So in smart farming technology, they actually apply other technologies, yeah. For example, like software, sensor technology, GPS technology, communication technology, and robotic technology, analytic technologies. And all this technology, right, in other industry is already quite mature. Just I share with you, I work in engineering industry for about 9 years. I work in a water treatment system. Yeah, that is an industry that we apply sensor technology, automation technology for many years. So it just happened they are not bring the technology from one industry across another and make the big change. Okay, and that is the opportunity that we see as well, and the potential that we see as well. It's just like Grab, yeah, that from IT bring into transportations and how actually they make the change and benefit all of us. Okay, so that's why, okay, no matter what is your expertise, I think you can think on how to apply in agriculture and make the change. Yeah. So what is the process taking place on farm using smart agricultures? Basically, this is a four normal step: data collections. The sensor will collect the parameters, okay, such as like soil, air temperature, your nutrient concentration, your pH level, and all that. So that is the first step, data collections. Okay. Second step is the diagnostic. Okay. Diagnostic is subjecting to your programs, how you actually programs, how to process the data, and based on the uh, you know knowledge and know-how, how actually you can diagnosis the problems. And then third is decision makings. Based on the data that you have, you know the system itself can make the decision based on the preset programs. And that is the actions. Okay, and the system itself should take actions to change, fine-tune the environment, and make it suit to the plant to grow. just for example some of the project like we did before, we control the hydroponic water parameters, like the nutrient concentrations. We have the EC sensor in the system. They will 24 hours monitoring the water parameters, yeah, the nutrient concentrations, and they will have the controller, you know, um, to take control, yeah, and they will trigger the some dosing pump, to adjust the nutrients, and so that the nutrient concentrations is always meet the perfect requirements of the plants. Yeah, so this is some of the simplest uh, projects that we did. Okay, case study of smart farming's application in aquaponics. Okay, so maybe I will further talk a bit about aquaponic, and then you can understand uh, our process on develop the smart farming system for our projects. Okay, aquaponics is not a very new technology. It actually happens like 1,000 years ago, so, but is using different methods. So last time they used the floating raft and float on the rivers, and they plant the vegetables on top. But as of now, aquaponics, they further develops and they combine this aquaculture system with the hydroponic system together, and so that you have a to produce, which is the fish and the vegetables from the same system. So the aquaponic process is actually a biological process. Yeah. So the waste discharged from the fish and they will be break down by the microbes, the bacteria, and to become nutrients that the plant can uptake. And then after that, the clean water will return back to the fish tank again. So in this process, the bacteria, the microbes, is like the engine in the car. Without this bacteria system, we are not able to convert the waste. Yeah, the waste is still the same waste, so not able to utilize. So the bacterial system is the key parts of this aquaponic system. In fact, this kind of process is not something new. It's also happened in the soil system as well. Just to imagine when you have a tree and the leaf drop to the ground and you have the earthworm, they consume this leaf and then they break down, become the poo, and then after that there's a microbes or bacteria inside the soil, they further break down, okay, further break down the solids to become the soluble nutrient. Okay, so this kind of process is similar in natural environments. Okay, so in aquaponic system we utilize the hydroponic mechanism. Okay, so my hydroponic mechanism, for example, the nutrients tanks, the water pump, planting system. But just that we don't use the fertilizer like hydroponic system is doing. Okay, but in fact hydroponic system had the advantages of, you know, like for example 90% less water consumptions. Yeah, so same goes to aquaponics as well, of course, because both of them are the closed loop system. Okay, so the water is recycling within the system itself. So that's why it's not like the soil farmings, conventional farming, that after you watering, the water may get it, go into the ground, yeah, or escape, or to the river or underground waters. So for hydroponic system or aquaponic system, they are enclosed system. Okay, so some of the advantages, for example, you can manipulate the nutrients levels to suit to different growth stage of the plant as well, and then you can increase the yield through these kind of manipulations. Okay, and for hydroponics or aquaponics system, they also have other advantages, that is, you are easily to develop that to become vertical farming. Okay, as of now, I would say 99.9 or up to maybe 100% of all vertical farming system in the world, they are all using hydroponics or aquaponics system, which is a water-based system. Okay, the reason is that it's easy to construct, it's easy to control, yeah, it's easy to transfer the nutrients from one to another, yeah, because of the medium is the fluid, it's not soil, it's not solid, yeah. So in aquaponic system, right, aquaculture system is one of the key part as well. So in this aquaculture system, they come with the biofilters. Yeah. So there are two stages of biofilter, that is mechanical biofilter and the biofilter. So they play two different functions. One is to trap the solids, and then another one is to break down the soluble waste to become the nutrients. And of course, in more comprehensive aquaculture system or aquaponic system, they even have the mineralization system that can further break down the solid into the soluble nutrients. Yeah, so they will achieve a zero discharge. Okay, so that is the potentials of aquaponic system. Yeah, so this is a process of a aquaponic system. As you can see, they go through a few different stages of a bacteria to convert the ammonia to become the nitrate that the plant that need. But of course, in this process, okay, they will release the hydrogens. Yeah. So after there are many R&D and research, there are certain parameters that we all know, okay, suitable for aquaponic system. Okay, so when we have this parameter, okay, then we will know that in order to ensure, okay, the best performance, we need to control and ensure the system is operating within these parameters. Okay. And one of the example, for example, why we need to control pH. Okay, this is a pH versus nutrient availability chart. Okay, there are different nutrients here, elements, right? And you can see that the bar thickness is different in the different pH level, correct? Yeah, so certain nutrient in pH, if they are too acidic or too alkaline, you can see the thickness of the bar is very thin, which also meaning that they are not available for the plants to uptake. They are inside the soil or they are inside the water, but just that they are not able to uptake by the plant. Okay, and pH control is important not only in the water-based system, but it's also on the soil farming system. Okay, but just in water-based system, hydroponic, aquaponics, we can manipulate the pH levels easier. Okay, even we have a 10 tons or 100 tons of water, because the fluid is completely mixed. You can mix the fluid, very effectively. So we can very easy to adjust or control or monitoring the pH level. We just need like one drop of water, then we will know that about maybe 10 tons of water parameters on the pH level. Okay, for hydroponic system, they also have a different parameters, like, for different crop, they need like different concentration of nutrient and also the pH level. Yeah, so that is through some of the research to get to know that what is the best parameter that suit to different type of crops. Okay, now after we know all these different parameter, what is the next? Okay, the next is we can utilize those industrial sensor that already quite common in the markets. Okay, for example, like pH sensor transmitters, DO transmitter, level sensor, weather sensor, okay, to construct the smart farming system to help you 24 hours non-stop monitoring, okay, the growing environment and do the immediately adjustment without any human interruptions, without any humans involvement. Yeah, that is the beauty of the smart farming, especially um, in our today life. We know that actually every one of us have a job, right? So we may not able to very committed, or spend too much of time in urban farming's um, activity or the process. That is how we can utilize the technology to help us. We can still practice urban farming, but with minimums times consumptions and the labor workforce and all that. So this is one of the pilot project that we started in cooperation with MDEX. Okay, we built this smart farming project for Alang Asli community. In this project, they actually come with two set, left and right. We are doing the experiments. Okay, left side is actually a hydroponic system with a smart control. Okay, another side is the hydroponic system with manual operations. Okay, so for the smart control, they come with all those automated pH and nutrient concentrations, monitoring and adjustments. And the left side is that completely manual. So we see the difference is that for the manual system, we need to ensure the Orang Asli is being well trained, and that is also very challenging. Yeah, because they may not from they are not from this agriculture field, okay, and also they got other tasks. They also got other daily work to do. So and also sometimes they have the difficulty to understand how is the process, or they may not able to memorize the steps. Okay, so that is the challenge that we facing if we want to you know encourage like those B40s or orang asli them to adopt farming activity or farming business. Okay, but I think that actually can be solved by technology. Yeah, that like this is what happens. We apply this smart farming system, and certain process is already automated. Okay, and we don't even need to get them to update for us for the pH level, AC level, or any growth condition and all that. Okay, we use our camera to monitor things remotely. Okay, we use our IoT system to remotely check what is the water level, the pH level, the temperature, and all that. So, what is the upcoming trend of smart urban farming? Okay, if you check on the global smart farming markets, okay, and also vertical farming markets, you will find that uh, there is booming now, and by years 2026, okay, they're also expected to have like 12.4 billion USD kind of a market size globally, okay. And let's see what happened in our neighbor countries like Singapore. Okay, Singapore, I think 2 years ago, they already set a target. They call it Singapore 30 by 30, which is they want to achieve 30% self-sustainable by year 2030. Okay, so that is um, one of the upcoming urban farming's development in the regions that we think will bring significant change to the industry as well. So some of the urban farming project typically for vertical farming, so they will go into these two model. Okay, it's either indoor farming with many layers, okay, and they apply horticulture slide, or the vertical tower system that can apply in outdoor environments. Okay, so this will be the trends for urban farming's developments, I think, in the near futures. Okay. Okay. Thank you. I think that's all. And then I think we should go into like a Q&A sections.
Thank you very much, Mr. Francis Chuah. Very enlightening presentation. Learning a lot from the various model of urban farming system that you presented. And I think it is very nice that you pointed out in the beginning, how food security, especially with the younger generation, how we should project that. Yeah? And it is really impressive for me to hear, to teach the youngsters to see that food, it's not just about money, exchanging money. Yeah? Because food needs to be produced somewhere. And we have to know how that food is produced, who is producing it. Yeah, I think this is key to look at how everybody is playing a role in what kind of food do we want to produce or to have. Yeah, and to have your I'm not sure. I have to check if there's any question on the chat. I think we have quite a number of. I look at the meeting chat, right, to see, do we have any question at the moment from the audience? Yeah. Okay. We have the first one at Mr. Chuah. Is the system modular enough to fit into a small PPR unit? Your modular system. Yeah. So maybe we can take that first. I will later look into other questions.
Yeah. So all these urban farming systems, right, that like that can be customized to suit to the environment. And also we have the small modular system to fit to the very small space.
Okay. Okay. So that is, I think, this is understandable, but I want to also look at maybe how you look at smart farming. Yeah. What would be the, maybe you can help me, because depending on computer and, what is the possibility if that computer system break down? How can we handle this?
So I think everything we need to have a backup system as well. Yeah. So even on last time when even we are in a very so-called critical projects that we do for like power plant and oil and gas before in my previous experience, you have actually a different a backup system. Yeah. So in case that this happens, and then what is the next? What actually need to do? Yeah.
Yeah. So you mentioned earlier, maybe like a smart system. Not everyone can work with this. You mentioned about the orang asli is difficult. When it comes to training. So who would be the best candidate or the best people to handle this kind of system?
I think for our younger generation, which is very tech savvy, I believe they have no problem to handle this kind of system.
Okay. And so, then how do we look at the education part? Yeah, working with equipment, or when internet is doing everything. So how much or what basic agronomic knowledge or farming knowledge? How do we transfer this? Because this is the challenge for me also. So how do we impart this? With the to know what is enough fertilizer, or what is the role of each component and this kind of thing. Yeah.
Yeah, exactly. I think this is actually how technology can help. Okay, because maybe for example, we have a limited agronomist, yeah, that they are the expertise on the plant and all that, right? But try to imagine, right? If we apply the smart farming system or IoT system, that they can connect hundred, or maybe up to like a few hundred different farm, and all those parameter you can centralize and we can connect, and mean to say you just need to have one expert, plant expert, that can help you to diagnose, okay, whether the plant, whether that is doing well or not. Even they can actually utilize this machine learning to help to do this visual analysis on the disease as well. So you can minimize some of the, the manpower in order to physically, go into the farm itself to check, to diagnosis, to observe. Yeah. So that is how we think through technology we are able to scale.
Okay. Fantastic. Another question is in terms of maintenance, cost of maintenance. With electricity or water, if you have this kind of utility intensive as well.
Okay, understand.
So yeah. So what is the cost, the minimum cost? What kind of smallest investment that you can do with this system?
Okay. When I show you the hydroponic system or even up to the very high tech like indoor hydroponic systems, right? So of course the cost for this is different as well. Okay. So and and even like smart farming system also you can subject to this which is the what is the requirements and all that. So okay, we can go into a lower cost, okay, or it can be a very high cost. Okay. So but what I want to say is that although sometimes we think like some for example indoor farming technologies, okay, the indoor farms, in fact it's very cost intensive. In fact they also come with the high operation cost, because of the energy consumption or that. But we want to say is that, okay, we have to start because, okay, energy, if you look back into like maybe 20 years ago, they already have plant factory, they already have indoor farmings, but they use fluorescent light. And now we use LED light. How many percent of the energy efficiency that we can improve already? Okay. What if another 20 years? Okay. So people will improve on technology, on the light technology to make it much efficient. That is for sure. Technologies continue go forward. So about the energy source, we are also, you know, you can imagine like 15 years ago, where is the energy source? And what is the future energy source? Like, now solar energy is getting popular. Okay. So the question is, okay, although today, okay, it still seem like high cost, but if we not start now, where when we start? Okay, technologies take time to develop. Okay, so we have to start somewhere, and some of the bottleneck, okay, or some of the challenge, right? Okay, we that will actually solved by other engineers as well, other scientists as well. Yeah, but I think we need to have options for food
Yeah.
system. Yeah, because you can see the urbanizations, they're actually going up. I mean, the city design, they're going up or going down, which is underground or going up, or it's getting higher and higher or going down. That is what happening today. They're not possible going wide because the earth is, the surface resources is limited. Yeah. Or you and also we want to do more deforestation, right? So no choice that we have built a city is going up or we're going down in the underground. Yeah. So in that situations, how we actually can grow more food in this kind of environment or setup? Only can going follow the shape of the city to go. Yeah. That is the situations. But of course, we know that is still some problem we yet to solve. Yeah. But it takes time to solve. Maybe another 10 to 20 years. We are solving the problem. We're trying to solving the problem that, 10 years or 20 years later.
I have another question, Mr. For his place, he has a place about 200 square feet garden. So which of the technique or the system do you think is appropriate for him to use? 200 square feet. And
Okay.
what would your recommendation for him?
Okay, so it's very subjecting to the objective. If you want to go for like lower costs, okay, but with easy to operate, right? So we recommend like go for like a small greenhouse because the greenhouse will protect the crop from pests. Pest is one of the issue, okay, quite a major issue. So a greenhouse, if you don't want to has troublesome with this pest issue, and then later on you have no choice, you have to use a pesticide on that. Then apply greenhouse, small greenhouse. Secondly, is that vertical farming is more expensive. Then you can apply the horizontal farming, horizontal and a hydroponic system. So that is the basics that you can start with. Yeah, that will cost like maybe less than 10,000. Yeah, or if you want to utilize automated dosing system, yeah, you can also include that.
Okay. And I have a question from Mr. Scott. Are these methods, I think the four methods that organic fertigation, hydroponic, and aquaponics, are these methods classified as organic farming?
Okay.
Okay. Yeah. How this classification? Yeah.
According to Malaysia law, okay, or regulation or certification, this is not classified as organic because there are no grow in soil. Okay, but Singapore is the first country that recognize water-based system as organic farming. Yeah. So the answer is no in Malaysia. Yeah. But if you look into like for example, okay, when you look into aquaponics process, aquaponic process is a biological system that convert the waste from fish to break down that become nutrient. Yeah. And so the plant can uptake. So my question to you is that if you organic farming, you use maybe chicken tongues, and then you also use the bacteria to convert it become nutrients, and then the plant uptakes, from this nutrients. So actually, process is more or less same, okay, but in aquaponics system, it's still not being recognized as organic farming because it's not in it's not in the soil conditions.
I think this is not just Malaysia. I think in many countries all over the world, there is this friction between the organic proponent and who are in the soil, especially those who use soil as a main medium. So in hydroponic, aquaponic, and fertigation, any part that soil is, I'm sure hydroponic maybe no soil at all. Aquaponic also no soil at all. Yeah, so it's just a closed system. Yeah. So okay, let's see. Maria Lee, she is pointing out. I think this is the question. Why do we go for this kind of like Singapore when we have so much of land in Malaysia? Yeah. And this is again, whether this technology, we specifically say urban farming in urban area. Yeah. So are we saying that in rural area this is not maybe the right thing to use? Yeah. So why do we differentiate this? Usually fertigation, hydroponic, yeah, and we talk today about urban farming and not rural farming. So is
Sorry,
there,
hello.
yeah, is there we are pushing, we are putting these three technology specifically to
Oh,
address urban farming. Yeah. So are
okay.
we saying they are not appropriate for rural farming?
Oh no, it's also appropriate for rural farming. Yeah,
Okay.
yeah,
And
it's also
since
applicable for
we,
rural farming itself.
yeah, so Miss Marie, saying why, do we in Malaysia, when we have plenty of land, yeah, that we want to push for indoor farming or vertical farming.
Mm. Okay, so that is actually a common question. Okay, so a lot of, yeah, in Malaysia, yes, we have, as I mentioned just now already. Okay, indoor farming itself is a technology. Okay, um, we as of now we don't need. Okay, but is it in future when by the time if we really need, are we able to pick up immediately? Okay, as of now we even actually do need local productions. We can import. Yeah, we can import also. We actually do need to local production. Okay, but what if, okay, what if you got no supply? What if they don't they don't export the food to you? We have to prepare. We cannot just wait until the day come that we need this technology, only we start to do.
Okay. Mr. Wan Ahmad asked, can we make the system run by solar? I think you mentioned about the source of energy. Yeah, the solar system, solar panel can also be used to run the system, right?
It's a two different part of things. Okay, solar system is to capture the solar's energies and convert to electricity, and of course one is converted into electricity, then you can use the energy as well. Yeah.
Yeah. I
So
think
it's just that what is the cost or setup cost and all this. So you see like maybe how much is the cost that you build the solar system, or how much is the cost that you just direct it from a TMP for energy supply.
I think because with this kind of system, we still have to look at the energy efficient use. Yeah, how efficiency, even solar system is not. If you look at energy efficiency, is not probably the best source of renewable. Yeah, I think it's quite intensive as well, the consumption. But it's also nice to note that even our government is putting a lot of effort to um, subsidize the grid system, yeah, and that will help with our electricity bill. Yeah, I think if you want to install, there is also some kind of incentive for
Mm.
consumers if they would like to go into energy saving behavior or consumption. Yeah. Okay. Miss Josephine Yu is asking how many varieties of plants for greenhouse home set mentioned by Mr. Chuah. Uh, yeah, plant varieties. Maybe you can share what type of plants are suitable for the system, and if with aquaponic, what plant and fish types, varieties or species or shellfish that can be integrated. Maybe we can share a bit on that.
Okay, so usually for our hydroponic or aquaponic system, they share the same planting mechanism. Okay, so the planting mechanism, for example, like hydroponic NFT, which is that you can see the horizontal tube, and then you have the pot on top, right? So that is NFT system. So for NFT system, usually it's suitable for leafy vegetables. Yeah, because the space for the root is small. Okay, you're not able to hold a bigger plant. So usually that will be suitable for leafy vegetables. So if let's say you want to grow like chili or terongs, so they will more suitable like for example fertigations, the polypacks that actually provide a better, bigger space for the root to grow. So subject to which type, what you want to grow, and then you can actually go for different type of the planting system.
What about in aquaponic type of fish or shellfish? Any specific that should be encouraged?
For fish, freshwater fish, and subject to the local weathers. Okay, so for example, in Malaysia, tilapia, patins, jack perch, they're actually a quite suitable fish in Malaysia. And
Okay. Okay, so my question is in the aquaponic system, for example, what is the main source of feed for the fish? What do they eat mainly?
Okay, so they mainly eat the feeds for fish farming feed. Okay,
Okay. So you use
so commercial fish farming feed. Yeah.
okay.
So of
So
course you
you
can
do
also feed them other thing as well, but it's just subject to like your time and your cost lah, effectiveness.
do you consider or have you tried using azola or duckweed in your system?
Uh, it's not that effective.
Okay.
Yeah, because it's actually we call it element transfer. Okay, nutrient transfer, element transfer. Let's say for example duckweed, right? You can actually grow duckweed easily, and I think they come with the nitrogen fixation kind of functions that can grab the nitrogen from the air and convert it to become protein. Okay, but try to be scientific is that right? The plant not just need uh, nitrogens, they also need any other elements. Let's try to imagine the duckweed, where actually they get all other nutrients come from. The duckweed also they need to get like where is the potassium, phosphorus, calcium, magnesium, and all these different others mineral. Okay, so even though the duckweed itself can survive by through this nitrogen fixations kind of features, but where the duckweed get other mineral? If the duckweed not able to get other mineral when you feed to the fish, right? They wouldn't create a new element. I mean, it's very basic chemistry knowledge because element we were not able to create. It's just a transfer. Yeah, whatever you input, whatever output, the mass balance is there.
Ms. Susan Xia asked, in the aquaponic system, do we harvest rainwater to be used for this
Can
farming system?
why not? Yeah, safe water can be used.
But would the chlorine in normal tap water affect the system?
I think the question is how was the rainwater? Rainwater have no chlorine, so if we
No,
use
if we tap
uh,
water, if we
if
would
you use tap water, the chlorine will kill the fish if the chlorine concentration is high. Okay, so for example, if you have a new fish tank, then you put in the new water from tap, and this new water that have a high concentrations of chlorine that able to kill the fish directly. So what you need to do, okay, you just put in aerations system and let it aerate for maybe 2-3 days, or even you just leave it there for like 4 to 5 days. The chlorine will escape. Yeah, then you can put the fish inside.
in your experience so far with the aquaponic system, for example, do you see any problem with or the hydroponic or any problem with pest and disease?
Yeah. So
What is the main common one that we face?
actually, same to others farming systems. Yeah. So as long as there is veggie, there is a food for the pest, then the pest will come. If you don't have the protection, so actually not much difference lah. Yeah, I would say. Yeah. So that's why greenhouse is still something necessary.
So what do we do then if, for example, the system is contaminated, right? So then we have to restart and clean everything. Is this how we do, or how do we manage this properly? Yeah.
Okay, subject to the what contaminations that you mentioned, if let's say you mentioned is about the pests come in. So if pests come in, actually the attack is the surface. Okay, so if let's say is disease, okay, come into the system. So in hydroponic system, they also can use a UV light to kill the disease. Okay, or maybe they after or maybe the situation is still not able to solve the problem, still not able to solve, then they have to do sterilizing for a system. Or they have to discharge the water and they have to do the sterilizing in the system. Or they can use the bacteria to kill bacteria as well.
So looking at your customer base, yeah, whom do you want to work with now? who are your main customer group of people you try to approach to use your system? Because I have a question, a statement from Ms. Shu. Yeah. So if we want to do this in our university, I think in University Cyberjaya, how can they work with you? Can they turn their pond into this aquaponic system? Yeah, how would you collaborate with universities or to look into this technology?
Okay. We actually can visit your university to understand your environments. Okay. So and then we can come up with a proposal for you and the cost as well. So and subject to your budgets. So either you, if the budget is too high, so maybe you think like want to DIY, then we actually can support as well. No, not an issue. We can actually give guidance on how to actually DIY and all that. No problem. And we also, because as I mentioned, we also now setting up the Urban Farming Training Center in Cyberjaya, just near to your university. So once this is done, then you also can send your student come here and then do visit, and then we do knowledge sharing, no issue. Okay, so another question to ask is who is our customer base? Is it?
Yeah.
Okay.
Maybe you can describe being what do you mean? You are social registered as social enterprise, right?
Yes, correct.
Yeah. So how does this affect your mission, your vision, and also your customer base?
Okay, so as a social enterprise, so the business model of social enterprise is actually we are focused on social project, but at the same time we are also an enterprise. So as an enterprise, we also need to make revenue. We need to earn and so that we can continue the social missions without need continue donation and all these things. Okay, so that is the difference of social enterprise compared to NGO. Okay, NGO they may not have a business model. They get the donation and then they run the projects. But social enterprise is that we have a customers and we deliver the value to customer and customer they pay us. And so that we can use this pay from the customer, we help somebody else, which is a beneficiary. So that is the difference. Okay, so what we do is that subsidizations, we call it cost subsidization model. That, for example, we set up a system for our customers, or we conduct some program for our customers, and then we use the part of the revenue and to help, to subsidize the education program for the school. Okay, this is one of it. Yeah, or we help we help other foundations to execute their CSR projects. Okay, so that is how we do. And of course, the difference of social enterprise is that also we need to come out the impact measurements mechanism. Yeah, so it's not just we deliver a project, that's all. No, but we have to see and monitor what is the change that we deliver. Okay, for example, when we deliver a program or project to a school student. Okay, so first of all, that is a change that we are targets. Okay, what is it? Which is like, improve their knowledge on urban farming or hydroponics or what, that, or upskilling. So we have to do the comparisons is before and after. Okay, before it's like what actually they know. We have to capture, and then after that, after our training, our program or project. So what they know. Okay, so that is a change of knowledge. And then further on is that if the project objective is like, let's say for example, increase their revenue, or help them generate income. So also have to capture like, okay, before that they maybe have a very small farm, not effective, right? So we had to measure what is the total revenue, and then after our project program training level system, then increase how much. So that is the impact measurements. This impact measurement have to be report to the payer as well. Yeah, something like that.
Yes. Thank you. Okay. We have about 5 minutes left, so let me just go through in case I miss some of the question. Okay. One here is KH San. What is the cost for hydroponics chemical? Is it possible to make these inputs by ourselves? Do you recommend this? What is your recommendation for this?
if, okay, for hydroponic fertilizer, okay, if the objective is you want to make it organic, okay, I don't know why he want to make produce by himself, okay, whether it's because cheaper cost or want to make it organic. If let's say you want to make organic, I would recommend that why not you go for aquaponic system, okay. But if you just want to make it cheaper, right, I think unless you're made in bulk, or else it's not going to be cheap if you want to produce in a small amount.
Okay. Because a few questions also is, how affordable the smallest unit of modular system that you can have, yeah, either for vertical farming or that can fit into PPR unit. Because I think I saw that you also advertise on Lazada or something like that for some of the unit, right? So what is the average unit cost, the smallest price for what you have?
The lowest started set aquaponic system, I think, is like near to 400 ringgit, 200 to 400 ringgit, yeah.
So I think that would answer that question. Let me go through a bit more and see if there's any new one. Okay, so far no. Okay, so before we close, maybe you could just share, give 1-2 minute, sharing how you see, how would you like, because we have various kind of people on our program now. We have about 50 plus audience, yeah. So what is your encouragement, or how do you see that we can work together, or how do you see that your product or your work can be uh, brought forward, so that everyone can benefit to improve their own food security at their household level at least. Please.
Yeah. Okay. I think first of all, I hope that everyone can be open-minded to this something. This the thing that we do today. Of course, there are also people will think like this is maybe it's too cost intensive and all that. That's right. But as I mentioned, we be open-minded. Okay, and then we try to see how to improve from time to time. Okay. So secondly is that we are also looking for cooperation with any others. Okay, so that we can create the right ecosystem to to develop urban farming. Okay, like for example, I was from engineering. Okay, and we thought that we are good enough, and then we do these urban farm businesses, and then eventually when also we think like there are actually involved so many things. Yeah, and in agriculture itself, it's also a science, okay, that involve like biotechnologies, yeah, that involve like the plant, plants, technologies, and all those different technical know-how that we also not really familiar, right? So, and of course, in order to make urban farming sustainable, we have to ensure it's also economically sustainable. That is how it can continue. If they're not able economy sustainable, so thing is that if you just not able to sustainable or not able to scale, okay, so there's no point. It's just like a showcase. So that is not something that we want. But how to make this happen sustainable in terms of the environment sustainable, economy sustainable, these two sustainable, we need to have many different talents to come in to join in, and so that we can make it happen. Yeah. Just for example, okay, from technical sides, maybe we are able to make it environment sustainable, we are able to produce in these environments and all that. But if we are still not able to commercialize it, okay, so nobody will continue the things. Nobody will further develop. So mean what? We need talent from like marketing, product development, to make this product reach to the end user side and exchange with a fair price. And that is how we can further scale urban farming and make urban farming can really survive in the city, and then contribute certain percentage of the food supply. We are not target like replace 100%. It's like, if let's say, what if 10% of the food we consume every day is from the city itself, and we are safe because no matter anything has happened, for example, like COVID, lockdown, all these situations, city itself is still sustainable, self-sustainable. We just eat lesser, but we're still able to survive. So that is our vision.
Thank you, Mr. Chuah. And I think I just would like to also add, that with since we are focusing on urban farming, I think it is also very important that we see the role of our municipal council. Yeah. In Because even as somebody at home, yeah, I have to know whether my building is good enough for this kind of farming. Yeah, the construction is strong enough to carry water or to carry the instrument, and at the same time, we probably will create some solid waste. Yeah, when we have all this, buy all this instrument. So hopefully, we can work with municipal council. Where do we dispose? At the end of the day, if that we want to throw away or recycle or reuse any parts of the system. I think when we look at sustainability, we have to look at all these other parts as well. And also on that note, I just want to mention that because I'm also involved in the development on the plant factory standards under SIRI. So we are looking at how a closed system like hydroponic or aquaponic, what is the responsibility of each of us when we go into this kind of farming. Okay, with that, I think I would like to really thank you, Mr. Chuah, for spending your time with us. And I can see that there is a marvelous comment from all our audience that you are right, that you share this knowledge with us today. And with that, I invite all our audience to give you a big clap and thank you for enlightening us. And I'm sure University of Cyberjaya will continue to be in charge, and the other audience can also probably get in touch with you. You can check their website. You can also, I Google you and I found you on Lazada, so I'm sure the other people can also do the same. Thank you so much, Mr. Chua, and I hope to see you again soon. Thank you.